Alright, I want to start off this video kind of reviewing what we've already talked about the Vertex form. And I think yesterday's video for the class, I did not include this page. So, okay, Vertex form is y equals a times x minus h squared plus k. And in the video, we said that h and k, not negative h, but h and k is a vertex where x, your line of symmetry, equals h. Okay? Your axis of symmetry, that vertical line, is still the same thing, h. All right? And since it said minus, what we do is we take the opposite of this, and that's going to be our x. It's also our axis of symmetry, so it'd be -4, and our vertex will be -4, and then this is our y. So with vertex form, you don't have to do any plugging in numbers or anything like that. It's all right there in front of you in the equation. All right, so for example, this one, the axis of symmetry is your vertex, your x-coordinate, the opposite of -3, so 3, and your vertex would be 3. There's nothing here, so it'd be 3, 0. This one, x equals the opposite of this, 5. So that's your axis of symmetry. It's also your x-coordinate of your vertex, and then that is your y-coordinate of your vertex. All right, on this one, we don't have any parentheses, right? So this is basically saying x minus 0 squared plus 3. This is the same thing as that. Okay, so whenever you don't have the parentheses, then it's saying that h, or your x-coordinate, is 0. Okay, the 3 is your y-coordinate. All right, so make sure it's only in parentheses when you have the x doing the opposite. Okay. All right, so to review graphing it, you do the same way you do quadratic standard form. The only thing is we don't have to do that opposite of b over 2a and then plug it in our axis of symmetry to find the y. It's all here. So our axis of symmetry is -2. My vertex is -2, 7. So I'm going to plug that in here. And let's go back. Okay, so if x is -3, then y will be, if I plug it in, you just plug in -3 where x is. So it'd be the negative of -1 squared plus 7. So the -1 squared is 1. So the negative of 1 plus 7, so it'd be 6. Remember, when you've got that on the outside, it's the negative of this answer, whatever it ends up being, okay? All right, and if it's -4, it's going to be 3. I'm going -1, 0, so it's going to be 6 and 7. Remember, these are going to be the same as these because this is your turning point, your vertex. All right, so let's graph these points. My vertex is -2, 7, 2, 4, 6, 7, so here. And then -3, 6, and -1, 6, and then that's a 3. 0, 3, 1, 2, 3, and -4, 3. All right, So there's your graph. All right, so domain, remember, domain is your boundaries left and right. So since you have your arrows here, it means it's just gradually going to get wider and wider. So your domain's always going to be all real numbers unless you have a sideways parabola. All right, our range is going to be dealing with y. So you're looking at your vertical. How is your graph doing vertical? Well, it never has a bottom because it keeps going and going. However, it does top out at 7. All right, so y is less than or equal to 7. All right, remember that the sign, you have to watch it. Is it everything below or everything above? Okay, if your vertex is a maximum, meaning it's at the top of the graph, then it's going to be everything below. If this was a minimum, then it's going to be everything above. Okay, just common sense if you think about which way the graph is going. All right. All right, so that's a review of what we were talking about yesterday, graphing in vertex form and how vertex form works. Let's look at transformations. All right, a transformation is when something changes. So first, let's talk about the most simplistic quadratic equation is x squared, y equals x squared. And this is known as the parent graph or either the parent function. Okay. So in other words, let's say if I had this in vertex form, it would look like this. My vertex would be 0, 0. Okay? On any parent graph, it's going to be going through or starting at 0, 0. Okay? So this is A is 1. Your origin is your vertex, and it's positive 1. So this is your parent function. All right? So any changes you make in your H or your K, your left to right movement and your up and down movement, are any changes you make as far as A is concerned, then those can show up as transformations. A transformation is a change to the size or position of a figure. Okay? All right, so let's look. This is your parent graph, x squared. Okay, this is your parent graph. And then they want us to graph this one. All right, so my vertex is going to be -2, 0, correct? There's nothing out here. And you take the opposite of inside the parentheses. So this is my vertex. All right, and it is positive A, so it's going to be going up. So this is a minimum at -2, 0. So I'm right here. So if I plug in some numbers here and I graph it, then I'm going to get, if I plug in 0, I'm going to get 4. If I plug in -1, I'm going to get 1. If I plug in -3, I'm going to get 1. And if I plug in -4 for my x, when I say plug it in, then when you work it out, you're going to get 4. So let's graph these points. We got 0, and then go up 4. And this is our axis of symmetry here, right? And then we have -4, 4. And then we've got -1, 1, and -3, 1. So we have this graph. So our transformation was that, let me do this one in red here so it's kind of, okay. So this is this graph, and then this is this graph, okay? So you can look, if you look, this is the origin at 0, 0. The graph stayed the same as far as its width and everything. It didn't go up or down, it just went this way. And if you look, it went 2 units, right? So it went 2 units to the left. Okay? So my vertex in this one was -2, 0. All right? So to the left is negative. So it's -2. And it didn't go up or down, right? So if my transformation would be 2 units to the left, or 2 to the left. Now, if you'll notice your equation, if I was writing from x squared, so if I got just x, if I went 2 units to the left, that's -2. So in the parentheses, it would be the opposite, +2, right? And then we didn't have any up or down movement, so there's nothing on the outside.
Hey, Miss
Okay.
Alicia, I need to answer.
Okay. And just let it sink in. Sometimes it's left and right, kind of gets people mixed up. But don't just give up on the first one. Just keep watching and listening. All right, on this one, number 8. We don't have any parentheses, right? So that means that my x coordinate's 0 and my y coordinate's 5. All right, so we're going to put 0, 5 here. And let's put -1, -2, 1, 2. And let's plug these numbers in. So -2 squared is 4 plus 5 is 9. -1 squared is 1 plus 5 is 6. 1 squared is 1 plus 5 is 6. 2 squared is 4 plus 5 is 9. So we'll graph these. -2, 9. 2, 4, 6, 8. That's the one up here. And then -1, 6. 2, 4, 6. Oops. 2, 4, 6 here. And 0, 5. 2, 4, 5. Then 1, 6. And 2 9s up here. All right, so I'm going to have this graph. Okay. It's still about the same proportion width. The only thing, we didn't shift left or right, did we? We still stayed on this line, the y-axis, but we did go up 1, 2, 3, 4, 5. 5. So we went up 5 is our transformation. Okay? And my equation tells me that. I didn't have any parentheses, so that meant my left or right movement was 0. And then this tells me to move my parent graph up 5. All right. Now, let's kind of look at it without graphing it. If my vertex would be -1, -6, all right? So that tells me that I went to -1 and then go down to -6, all right? So I went 1 left and 6 down, okay? This tells you that. When I write the equation, when I put that in the equation, I just change this to the opposite, and there's my equation. All right, let's look at this one. My vertex take the opposite, 4, bring this down 1, so 4, 1. So we are going to go from origin, we're going to go over 4, and then up 1. So we went to the right, 4, and up 1. Okay, so my graph looks like that. Here, my graph looks like that. Okay. And, okay, let's look at this one. If you notice on this one, my A is greater than 1, okay? So let's see what happens with these, all right? So let's look at our vertex. My vertex, I don't have a parenthesis, so that means my x is 0, and then -7 is my y coordinate. So if I plug these in, see, this would be +1, 2. So 3 times -2 squared is 12, minus 7 is 5, and then 3 times 1 is 3, minus 7 is -4, so that means this is -4 and this is 5. So let's graph these points. This one's a little bit different because A is not 1. That's all we've done so far today. All right, so we got -2, 5, it's here. -1, 4, it's here. Oops, no, that's not -1, 4. My bad. Let me erase that. It's -1, -4. So it's down here. And then 0, -7. 2, 4, 6. So that's down here. Then 1, -4, and 2, 5. So this graph looks like this. Oh, that's crazy. Look, it's stretched out, isn't it? It's kind of like they took this one and just pulled it and stretched it out. All right. So that's showing me if A is greater than or equal to 1, if it's greater than 1, then you stretch the graph. The graph is stretched, okay? Or it becomes more narrow. All right? And usually, if you're, they tell you it's stretched by a factor of something, which will be A, okay? So this graph, we didn't move left or right, okay? The X tells me my left or right movement, right? My Y tells me my up and down movement, and then A tells me
Yesterday.
if it stretched, and it also tells me if it goes up or down, right? If it flips, okay? So this one, we went down 7, because it told us there. We didn't move left or right, because it told us there. And the 3 told me that it stretched by a factor of 3. Okay. All right, let's look at this one. All right, now this one, A is negative, so we know our graph's going to be going down, but it's a fraction. So I guarantee you it's going to look, instead of stretching, it's going to do something else. All right, so let's look. All right, my x coordinate's going to be the opposite of this, so 3. And then this is my y coordinate. I wrote y. That's going to be my y coordinate, -2. All right, so this tells me that we went to the right 3. And this tells me that we went down 2. All right, and you can go ahead and graph it over here. 3, -2 is here. And I want to go ahead and graph this entire graph so we can see what happens when a is a fraction. All right, so let's plug in 1, 2, 3, 4, 5. You're going to get -4, -2.5, and -4. So if I graph these points, I got 1, -4, 2, -2.5, which is halfway. Same here and here. So now this graph is going to look like this. So it's wider, right? It's getting wider as it moves out. So it's kind of like somebody sat on it and squished it out, all right? And they call it, they use the word, trying to find some room here to write. It was compressed, or it became wider by a factor. And we're not going to put the negative on there. It's just the 1/2, okay? By a factor of 1/2. Now the negative also tells me this way is facing up, now it's facing down, so it also flipped across the x-axis. Okay, and it's always flipped across the x-axis if it's a negative a. All right. All right, let's see. So, if H is the blank shift. So shift is when you're shifting to the left, shift to the right. So it's the horizontal shift. So a plus sign, now this is what they're saying, if I had like x plus 2 squared, all right, then that means it's the opposite, so it's negative, right? So I'm going to shift to the left. If I had x minus 3 squared, then the opposite's 3, so I'm going to shift to the right. Okay? Just everything in that parentheses is opposite. So if I got a negative here, I'm going to shift the opposite direction. Positive on my number line. All right? Just anytime you're translating from here or to here, you're doing the opposite. Okay? K is the vertical shift. You don't have to worry about anything here. Plus means up, and minus means down. Okay? If A is negative, the function is flipped. Well, let's use another word. Reflected. That sounds nicer, it's prettier, isn't it? It's reflected across the x-axis. And and they say absolute value. So if A is greater than 1, that represents a vertical stretch. I cannot spell today. And if A is between 0 and 1, which is a fraction, so if it's a fraction, then you're going to have a compression. Okay, so stretch means it's gotten narrower, and compression is it was wider. Okay. All right. Before we do that, I want to. All right. Transformations of the parent function. Parent function is this, right? So if I want to write a new equation, and it was like the parent function, but it went to the right 2 units. So we're going to move it to the right. It was here, so now we're going to move it over here to the right. Okay, so if I want to write an equation, it'd be y equals, now I'm going to put it inside the parentheses. What goes on when we're taking out or putting back into the parentheses? You do the opposite world, okay? This is opposite land. So right would be plus 2, but inside the parentheses, we're going to write minus 2, okay? Did we change anything going up or down? No. All right, the only thing we're changing was our horizontal shift, okay? All right, this one says we had a parent graph, but we translated 5 units up. So you're just going to write the parent graph and go up 5. All right. This one says it translated 3 units left and 4 units down. So y equals, so in my parentheses, 3 units to the left, that would be going this way is negative, right? Negative 3, but inside you do the opposite, positive 3. And then 4 units down would be negative 4. All right. Translated 7 units to the right, so that's positive 7. And then up 4, which is positive 4. So we're going to write it. This is just like my vertex, y'all. X opposite minus 7 square plus 4. All right. Reflected, so that means my A is negative. So y equals negative, and it's translated 3 units down. So we didn't change anything with the x, so we're just going to leave it x squared. And then it went down 3. Okay, and reflected over the x-axis, so again we got a negative. It says then it translated 5 units to the right, so that's plus 5, right? And then it went 2 units down, so that's negative 2. So there's my horizontal and my vertical. So horizontal, we always put it in the parentheses as the opposite. And then the vertical stays like it is. All right. All right, it was vertically compressed by a factor of 1/3, then translated 8 units up. So compression or stretching is our A. So our A is going to be 1/3. Y equals 1/3. And then it translated 8 units up. So our parent graph is that, right? So that didn't change, the x squared, because we didn't change left or right. But then it went 8 units up. Okay? So we're going to have that. And vertically stretched by a factor of 2. So that means my A is 2. So y equals 2. And then it reflected over the x-axis. So that means that's a negative 2. And it translated 4 units to the left. So our x is going to have to, 4 units to the left is negative 4. So inside the opposite world here, our parentheses, we're going to put plus 4. Okay? It didn't change any up or down, so we'll leave it like that. All right. Oh, whew. Jump over here. Well, maybe not. Let's go back. Let's go over here. And I want to show you these because you're going to have some work where the problems look like this. All right, it says write a new equation for the transformed graph. All right, so you're going to be writing an equation. It says given the graph y equals x squared. So this is a parent graph, right? It says write a new equation if the graph shifts to the left 1. So we're going to the left 1 and down 3. All right, left 1 and down 3. So our vertex is negative 1, 3. So if I'm going to write an equation, it's going to be x, this goes back into opposite world, plus 1 squared, and it's going to go down 3. Oops, that's a negative 3. Okay. Let's look at number 2. Okay, so we've got, this is y equals x squared. And it says that it shifts to the right 2. So it went to the right 2, and then it went up 5. So its new vertex is up here at 2, 5. All right, so this needs to become y equals x. I shifted to the right 2, so the opposite of that would be minus 2. Don't forget your square, because it is a quadratic. If I didn't put my square there, it'd become a straight line. All right? And then we went up 5, so plus 5. All right. All right. This one, it flipped over the x-axis, or reflected, so it's going to be going down. So y equals negative. And it's stretched by a factor of 3. So 3. And it shifted to the right 2 and down 4. So it's gone to 2, negative 4. So that becomes x. Instead of positive 2, we went minus 2 squared. And then it went down 4, so minus 4. Okay. This one, it flipped over the x-axis, or reflected over the x-axis. So it's y equals minus, and it's stretched by a factor of 1/4. So a is 1/4. And it shifted to the left, so it went to the left 3 and up 2. So negative 3, 2 is our vertex. So that would look like positive 3 squared plus 2. Okay. All right. Yeah. Now, look at this one. I got you 2 graphs. Here's your parent graph, and here's your second graph. So what happened? So my vertex here on my parent graph, and now here's the vertex here. So if you look, it went to the right 1, 2, 3. It went to the right 3. And then it went down 1, 2, 3, 4, 5. It went down 5. So my new vertex is 3, negative 5. So if I want to write a new equation, and it stayed the same width, but it did reflect, didn't it? One's going up, one's going down. So it's going to be negative x minus 3 squared minus 5. All right, the negatives for the reflection. The minus 3 is the opposite of our x coordinate, and then the minus 5 is our y coordinate. All right. This one, it was 0, 0, and it just went down 2, didn't it? It didn't go left or right, but it did get wider. It's one thing it doesn't tell you by how much. Let's just say by a factor of 2. All right, so it was compressed by a factor of 2. So it'd be y equals 2x squared, because there's no shift left or right, stays the same, and it went down 2. Okay, so they got wider and went down 2. And let's see, this one's stretched. Factor 1/2. Same thing over here. Stretch 1/2. All right. This is basically the same thing, except it's stretched. It just went down 2. It didn't go left or right, so it's y, but it did flip. Okay, in this case it did reflect, right? Flipped over the x-axis, so it's got to be a negative 1/2 x squared minus 2. Okay, it reflected and stretched it by half. There's no parentheses because we didn't move left or right, and it went down 2. Okay, we didn't go up or down, so there's still positive. It was stretched by a factor of 1/2, and we did go to the right 1, and we didn't go up or down, did we? So this becomes x, and it's plus 1, so this becomes x minus 1 squared. We didn't go change up or down, so we stay the same. And 2 more. All right, this one, they stay the same here. But we did shift to the left. 1, 2, 3. So we shifted to the left 3. Whoops, I went too far, didn't I? We shifted to the left 2. 1, 2. Then went down 1, 2, 3, 4. All right, and we did reflect. We flipped over, right? So y equals negative, and we put the opposite for our x coordinate, so x plus 2 squared, and then we put the y outside. And over here, this did get a little wider, so we're going to say it was compressed by 2. All right. Okay, so did it flip? No, so it's going to be positive. It was compressed by a factor of 2. And then my vertex, it went from 0, 0 to the right 1, positive 1, but it didn't move up or down, so that's 0. So x, the opposite, minus 1 squared. It didn't move up or down, so we don't put anything there. Okay. All right. Yeah, these just take practice, but once it clicks, it's easy stuff. Okay. All right. That's all I've got for today. It's kind of long-winded there. All right. Have a good evening.